Welcome to lesson 1 of looking at Internet and Web fundamentals. In this lesson, we're going to look at what is network, key components of the network, objectives of the network, topologies, client-server architecture with an example, and finally, look at how does network work. This is the first video in my series where I'm teaching about Internet and Web fundamentals. I've also shared the link to the article about this lesson in this video description. My name is Mulombi from Mulan Technologies. If you have not subscribed to my channel, kindly do so. Hit that notification bell icon to receive instant updates whenever I upload a video in the coming days. Leave your comment below in the comment sections and share this video to help your friends know about it. Let us start. What is a network? A computer network can be described as a system of interconnected devices, commonly referred to as nodes, that can communicate using some common set standards or rules called protocols, which are used to transmit information over physical or wireless technologies. These devices communicate to exchange resources and services. These devices are connected to each other using physical media such as copper, fiber optics, or they can also be connected wirelessly. Guys, in this diagram, we can see 4 computers and 1 printer connected to each other using copper wire as a physical medium with the switch as a central connecting device. This is an example of a network, and one of the resources being shared here amongst the 4 computers is the printer. Then let us look at key components of a network. What is a network made up of? Most basic networks are designed to connect users and enable them access various resources like internet, printers, and other shared files. Networks are comprised of 4 basic elements, which are hardware, software and protocols, and the connection media. All data networks are comprised of this element and cannot function without them. What are the hardware components? The backbone of any network is the hardware that it runs. Network hardware includes things like the network cards, routers or network switches, modems, and Ethernet repeaters. Without these hardwares, computers have no means of accessing a network. Network cards gives computer a direct access to network media and enable them to connect to other equipment, including routers, switches, modems, and repeaters. Routers or switches allow a single network connection from a modem to be divided between several computers. Then the second component, that's the network software and protocols. Network software refers to a wide range of software that streamlines the operation, design, monitoring, and implementation of computer networks. The primary form of software protocols that refers to software which instructs network devices on how to connect to the network and how to interact and communicate with one another. Networking software eliminates the dependency on hardware by streamlining communication across multiple devices, location, and system. Guys, example of a protocol in this component is what referred to as TCP/IP that allows different types of computers to communicate with each other over the network. Another component is what referred to as the client devices or nodes. Client devices are the computers and mobile devices connected to the network. Client devices are a vital component of a network, as without client requiring access to the network, then it's essentially pointless. Another key component, and one of the most important, are what we refer to as the connection media. Connection media refers to the medium used to connect the nodes of a network and varies with the type of network. Connection media, they are categorized into two categories, that is wired media and wireless media. What are wired media? Example of wired technologies or media used in network include things such as the coaxial cables, phone lines, twisted pair cabling, and optical fibers. Then with wireless, network connection can also be established through radio or other electromagnetic signals. This kind of transmission is what we refer to as wireless. The most, the most common example of wireless links includes communication satellites, cellular network, and radio technology spread spectrums. What are the key objective of computer network, or why do we have computer network? Computer networks have the following key importances. Number one, resource sharing. A network allows data and other resources such as files, printers, and media to be accessible to every pertinent user in an organization. You can be able to share files and resources such as printers. Number two, streamlined communication. Networks are critical for email, instant messaging, and faxing capabilities. For example, employees can share files, view each other's work, sync their calendars, and exchange ideas more effectively. Number three, key objective of a network. Network centralize data and make it more accessible, which increases the efficiency and need with which this information can be accessed. Resource availability and reliability. A network ensures that resources are not present in inaccessible silos, are available from multiple points. The last objective of a network is what referred to as the secured remote access. Guys, computer networks promote flexibility, which is important in uncertain times like now, when natural disasters and pandemics are ravaging the world. Give an example of the COVID-19. A secure network ensures that users have a safe way of accessing and working on sensitive data even when they're away from the company premises. Now, after looking at the key objective of a network, I understand there are many. I want us now to understand different type of computer network that we have. Number one is what we refer to as the local area network. What is local area network? A local area network is a group of computers that are confined to a small geographical area, usually building. For example, when you look at this figure, the circle, it implies something like a building, and inside that building we are having different computers that are interconnected to each other using switch. So this is an example of a local area network. It can also be in an office. Several computers or nodes are interconnected to each other within a small geographic area. Setting up a LAN or local area network requires computer with network adapters, central connecting devices to connect to those together like the switches, and numbering scheme, which we refer to as the IP addresses to differentiate from to differentiate from one computer to the next. We'll be talking about IP addresses in the subsequent lessons. Usually, LANs utilize one of several Ethernet standards. Ethernet is basically a type of protocol we talked one of the component of a network, their software and protocols. So Ethernet is just a set of rules that govern the transmission of data between network adapters and various central connecting devices. Another type of network is what we refer to as the campus area network. Campus area networks are a collection of interconnected LANs. They are used by large entities such as universities and government. Let us look at this diagram. This is an example illustration of campus area network. We see we're having one building that is the hostel, we're having one building that's the college, we're having another building that's the library, and we're having another building that is the lab. They are interconnected to each other over the internet. So this is an illustration that you'll find in most of the university. We have one faculty here, we have another faculty there, we have another faculty in another building. Then they are interconnected to each other over the internet. It's also used in government entities. Another type of a network is what they refer to as the metropolitan area network. A metropolitan area network is a computer network that is larger than that in a single building local area network and is located in a single geographical area like a city. Let us take an example of a city. We have different buildings with lands. So each lands, like for example in this diagram, each lands combined together, they form what we refer to as the metropolitan area network. That's MAN. It's confined within that's like a city, or it can be like a town. It's not in one geographical building, just a single city. Another type of network is what we refer to as the wide area network. What is wide area network? Wide area networks cover large areas such as large cities, states, and even countries, and are always established with less telecommunication circuits. Businesses as well as government entities use wide area networks to relay data to staff, students, clients, buyers, and suppliers from various locations around the world. Let us think of a wide area network. Let me give you an example of a bank. A bank has different stations or branches. These branches are not connected to each other locally. They are not connected via local area network. They are connected to each other because they are based in different locations. They are connected to each other with wide area network. Then guys, I want us to look at network topology. What is network topology? Network topology refers to the pattern or hierarchy in which devices or nodes are connected to each other. The organization of these devices that form a network. Topology, they may also be described or describe how data is transferred from one node to another. There are two types of network topology. We have one referred to as the physical topology and the other one called logical topology. Physical topology emphasizes the physical layout of the connected devices and nodes. That physical layout, how computers are organized, that physical layout is what we refer to as the physical topology, that pattern. Logical topology, on the other hand, focuses on the pattern of data transfer between network nodes. The physical and logical network topology of a network do not necessarily have to be identical. However, both physical and network topologies can be categorized into three common basic models. Number one, star topology. With star topology, all the nodes in the network are connected to a central device like a hub or a switch via cables. Failure of individual nodes or cables does not necessarily create downtime in the network, but the failure of that central connecting device can. This topology is the most preferred and most popular model. Look at this diagram. That's an example of a star topology. Central connection device, it can be a switch or a hub. The second type of topology is what we refer to as the ring topology. With ring topology, all network devices or nodes are connected sequentially to a backbone, which ends at the starting node, forming a ring. Ring topology shares many bus disadvantages, so it is limited to network that demand high throughput. The last type of most common topology is what refers to the mesh topology. When you have mesh topology, each node is directly connected to some or other nodes present in the network. This redundancy makes the network highly fault tolerant, but escalated cost may limit this topology to a highly critical network. As we'll be going around interacting with network concept, there's some terminology that you'll be coming across with an IP address. An IP address is just that unique number that assigned to every device or node connected to a network that uses the internet protocol to communicate to each other. Each IP address identifies the device, host network, and the location of the device on the network. Another type of terminology that you have even had me mentioning is what referred as a node. A node is basically a connection point inside the network that can receive, send, create, or store data. Each node requires to provide some form of identification to receive access, like an IP address. A few examples of nodes include things such as computers, printers, modems, bridges, and switches. Another type of common terminology you'll hear what referred to as the router. A router is just a physical or virtual device that sends information contained in packets between network. So it interconnects different networks. So routers will analyze data with the packets to determine the best way for the information to reach its ultimate destination. Another type of common terminology is what referred to as the switches. A switch is just a device that connects other networks and manages node-to-node communication with a network, ensuring the data packets reach their ultimate decision. When a router sends information between networks, a switch sends information between nodes in a single network. When discussing computer network, switching refers to how data is transferred between devices in a network. In addition to the computing devices, there are many network-enabled peripherals that we have seen, such as printers and scanners, which also connect to the network. All these devices or nodes use a wired or wireless network interface controller, also termed as network card or wireless card, to connect to the network. This controller has the electronic circuits required for network communications. These network cards of various devices are connected through wires or switch or a hub, though it's rarely used now, while the wireless cards connect to the network using access point. Computer networks work according to a set of well-defined rules called protocols. All the devices connected to a network follow these rules for communicating with each other. These rules, as I have said in my topic, in this topic, are termed as protocols. The operating systems, such as the Linux, Windows, Mac OS, and Android, running on computers have special software, commonly called network stack, which takes over from the user applications and carries out all the network communication related, processing until the data is sent out of the network interface controller. The network stack similarly processes the incoming data from the network and hands it over to the application. As we approach the end, I want us to look at something referred as the client-server architecture. As a web developer, this is something that you'll be interacting with when you'll be developing those web applications, when you'll be working with website. This is a terminology that you'll be hearing and you'll be interacting with during your development lifetime. What is client-server architecture? The client-server architecture refers to a system where host computer, normally referred to as the server, delivers and manages most of the resources and services that the client requests. In this model, all requests and services are delivered over a network through an established communication channel or session. With client-server architecture, typically features multiple users, workstations, PCs, or other devices connected to a central server via an internet connection or other network. The client sends a request for data and the server accepts and accommodates the request, sending the data packets back to the user who need them. Example of the client-server architecture are web server. What are web server? These are high-performance servers that host many different websites and the clients access them through the internet. Just to give you a brief of how it happened, here you see a home user who is connecting to in the internet. When the person wants to go to a website such as Bing, he or she just opens a web browser and types http www.bing.com or any other shortcut. The web browser is the client application in this case, and the Bing's web server is an obvious the server. It serves the web page filled with glorious HTML code. The client computer's web browser decodes the HTML and fills the user's display with the internet goodness. Another example of client server architecture that the emails client. If you use an email client program like Microsoft Outlook, Outlook is the client application in this case. It connects to a mail server, most likely an SMTP server, and perhaps run by Microsoft Exchange server. Guys, I know it has been long, but thank you so much for watching this video to this end. In the next video, I will be talking about OSI reference model, what it is, why it was created, and how information gets transmitted on its various layers by giving an example. As I have said, I have shared that's a link to a comprehensive article about this lesson that you can read at your own free time. Check on this video description. See you there. God bless you.